Welcome to the last lesson of Swift Memory Management with Bob the Developer. In this lesson, you will learn at which circumstances you may use escaping as well as autoclosures. No fear closure with Bob the Developer. Let's get started. Welcome to Learn Swift with Bob the Developer. Today, let's talk about the escaping and autoclosure. These are pertain to working with the functions, okay? We're going to talk about memory management within functions and closures. But here's the problem statement. What are those? So when I first learned Swift, and then when I opened up somebody's code in GitHub, and I saw a bunch of words like escaping and autoclosure, I'm like, what are those? So that's the problem statement here. So today, let's talk about how to make this thing, how do you use this, and when to use this, and then talk about why after. Okay? So let's talk about how to make this happen. How do we have this escaping thing right there? So first of all, let's have a scenario one. We have closure blocks. Again, we're working with functions and closures. And then you're going to create a functions, and that what it's going to do is the functions take that closure block and then append to this array block. Okay? Let's try to do that. So I'm just going to copy and paste. Right now, ignore this. So the function with closure, enter a closure block, okay? And then you're going to append to this closure block right there. But now it's going to ask you, hey, you got to add this thing we call, you're going to have to enter escaping. If you take a look at it, click on it, fix it. I love Xcode 9. It's going to ask you, hey, enter this escaping right there. But why is this happening? Why do you need to do escaping? All right, here's why. If the closure block can be executed after the function finishes, right? For example, function done, right? Function has been done, but the closure block that you've entered can be executed later because you can do something like this. Closure block, access the closure, and then run it, right? That means you're running the closure block right there. Okay, that closure block, you have to use escaping. Okay, again, that's a rule. That is a rule, and we'll talk about motivation later. If the closure block can be executed after the function returns, but it doesn't mean you have to run this closure block. If possible to be executed after function finishes, you have to use escaping right there for a parameter. Right, escaping only applies to parameter for functions. Okay, that is a rule. Talk about the motivation after. Okay, let's talk about scenario 2. Well, for scenario 2, you need to understand what it means to use background thread, asynchronous code. If you're not familiar with asynchronous code, go to. I've attached an article about Grand Dispatch Central. Go to that article in the resource page, and you will learn a lot more about how to use background thread and so on and so forth. So now in this case, you want to create a function, func with networking closure, and then you're going to enter the closure block, which will be executing the background thread, such as networking code downloading. You want to do it in the background thread because you want to block the UI, right? When it comes to networking, you don't want to block some, like when you use Snapchat, you don't want to freeze up your phone while networking, because networking is not as important as the UI. The UI is the most important part. That's what the UI is on the main thread. Anyway, so you're going to execute this closure block, but it's going to complain. But you're going to use Grand Dispatch Central, dispatch.global, async. If you're not familiar with async or global, this kind of stuff, I recommend you guys to go to my blog and in the article called Dispatch Central. Go read that and come back after. Okay, but now it's going to ask you, hey, you got to use escaping right there on the bottom as it states like this. It's right there. Escaping right there. But why is this happening? Well, again, if it's a background thread, that means this code, this closure block, will continuously run even after the function returns asynchronously. For example, when function done, when you execute this closure block, like that, networking, you're going to enter the closure block. for some like let's call it downloading something. If you take a look at it, the function has been already returned on the bottom here. The function has been done. However, the closure block is being executed even after the function returns. And when you go back here, if the closure block can be executed after the function finishes, you have to use escaping. So there are two scenarios. We talked about it. One is working with in the background thread, and the first one is being stored into closure blocks. That's why when you'll see a lot of completion handler things like that when you're working with escaping. I'm not going to talk about networking code, but you'll see a lot of completion handlers. You guys probably seen it before with the escaping. Okay, well, if you're interested in learning more, take the next course. Okay. Anyway, so you have scenario 2 and scenario 1. We talked about it. Okay, cool. But how about functions? How about closures that does not have escaping? What is the difference? So we talked about how to make this thing happen. We'll learn about the rule here. But why? What is the difference? Okay, let's talk about the normal function first of all, and then come back after. So we have a function, a normal function called Bob, right? And then you have a function called normal function with closure. You're gonna enter a closure block, okay? And then you're gonna execute the closure block by entering self.name, okay? Well, you guys might be thinking there might be a retain cycle going on because, as you know, there's a closure block, and the closure block has a reference to self. There's a possible retain cycle, right? You might be aware of those, right? We talked about in the last lesson. Retained functions are a reference type. Functions are closures called global closures, and closures are reference type. When you're working with self, there's possibly a retain cycle. But here's the problem. Here's the thing. So now, when you do normal, create an object, and they call this normal function with closure, enter name, and then print name. All right, you're gonna enter name property, and then you just enter my name. Okay, so right now the name is Bob. Okay, but you might wonder, is there a retain cycle right now? Well, there's no retain cycle. Here's why. Here's what's happening. So by default, functions, we call this, so by default means normal functions closures are non-escaping. So what does that mean? What does it mean by non-escaping? This closure block right here will be deallocated, again, removed from RAM by the time the function returns, by the time function finishes. So when you're working with this function, what's happening is this closure block is being allocated instantly and then deallocated, removed from memory as soon as the function returns. Okay, so closure block deallocated. Again, closure is like memory, right? And then they deallocate right after the function finishes. But for non-escaping, however, we talked about it, closure blocks are created by the time you run this function, but that closure is not being deallocated. It is still running, either being stored into an array or it is still running in the background of code. It's not being deallocated right after. That is a rule. Closures are deallocated. That is a fundamental reason why I need to use escaping, right? But you might ask, why is a closure non-escaping? Why is a closure being deallocated right after? Well, here's a benefit. Normal, anything that does not have non-escaping, does not have escaping is non-escaping, meaning the closure is being deallocated. It will be is not escaping out of the function. It will be removed right after the function returns. There's no retain cycle for non-escaping. Here's why. Because you know, right? You know the closure block will be deallocated no matter what. It doesn't matter whether you have reference to self or .name. It will be deallocated right after you call this function at all. So when you're working normal functions, don't worry about retain cycle. Okay, even if you have a self.name, there's no retain cycle. Again, I have myself because you know this closure block will be deallocated right after. Okay, retain cycle occurs when things are not deallocated, but if you know the closure block will be deallocated, then It's all good, right? And so you may use, so here's a benefit of using non-escaping when it comes to working with functions. You may use self keyword without worrying about memory leak. I talked about it. When you're working with self, it's kind of like a danger sign. Hey, you're referencing something else out of different object. Be careful for memory leak. But when you're working with self the name, as I said, you don't have to care about it. When it comes to functions, don't care about memory leak or routine cycle. If the closure block right here is what I call that non-escaping, just if but in other words, if it's normal, don't care about memory leak. But when it comes to escaping, be careful about memory leak. Okay, that's the rule. And then also, lastly, which I don't really have knowledge about, is performance and ability to compiler to optimize your code. Well, I don't exactly know how things work because I haven't looked into the C++, the code base of Swift, and I don't really know much about compiler. But what I can tell you is, if it's escaping, if the closure is being deallocated, that means life becomes much simpler, and the compiler can tell, okay, this closure will be deallocated. Just check once, done. But when it comes to escaping, I think the compiler has to check multiple times, keep counting where the closure is at, what the closure is doing right now, because you know this closure will be somewhere else in memory, and the compiler has to kind of track the closure block. But when it comes to non-escaping, the closure will be deallocated right after. The compiler just know exactly, just check once, done, that's it, boom. So that's why it's a performance ability to compiler to optimize. That's why Swift have decided to make functions, closure blocks, by default, non-escaping. Okay, I think that's a new feature in Swift 3. I think it used to be everything was escaping, but now they've converted to non-escaping to have this kind of, what do you call that, benefits of non-escaping closures, right? Use self without worrying about memory leak. How good is that? Okay. So hopefully I made myself clear when it comes to why we use escaping and why Swift is of functions closures are non-escaping by default. If you understand that part, everything else is easier. Hopefully I made myself clear. Okay. Again, also remember the rule that closures are deallocated right after the function returns finishes. Okay. So hopefully we finished the first objective, which is escaping. Let's go to the autoclosures. What are they? Okay. All right, I feel great because it took me a little time. It took me like I think recorded 5 times to make this happen, to get the escaping done. It has been what do you call that? Reopened. I guess it allows me to talk about the process of making this video. Yeah, it just took me a little while. I think recorded like 5 times, but as long as I'm making this good, I'm feeling great. So it's benefit of the escaping right there. So now let's talk about autoclosures. Why do we use autoclosures? So first of all, let's create a function. And then contains check ID card functions, and you're gonna enter has card closure block, and then you're gonna enter if it has card is true or false, you're gonna return true or false, right? And if it's true, then print you have an ID. Okay. But yeah, this example can be silly, but I'll make sure come back to why you use autoclosures. So now you have the ability to choose check ID card, and you have multiple options. You can do return true, okay? And when you execute this has card, you're gonna return true. So you've got an ID right there. There are multiple ways to run this ID card, right? And you can also use what? True, return true. And this is too complicated. Let's do this way. Like that. Actually, we don't need like that, just like that, because if there's no parameter, again, if you remember correctly from chapter 3, you can do simply like this, using trailing closure as well as, just skip the return part, or we can do check ID card. You can do true. Okay. But now, if you think about it, this is kind of why it feels kind of odd to use this kind of thing, right? Why do we have to use closure block like this brackets? It's kind of like disturbing me, okay? There must be a better way. How can you make this more readable? How can you make this? Because you're simply entering what? You're simply entering true or false, right? But do you really need this brackets on the left and right? Well, here comes a closure block. Oh, sorry. Here comes an auto closure that save your lives. So exactly the same thing. Check ID card, and then has card, and the only difference is you're gonna have the auto closure on the left side of this closure block, okay? And then everything else is the same. But here's the magic. Now you have the ability to call check ID card and simply use what? True. Right there. It works like charm. Yeah, it works. So if you, let's go back. Check ID card. If you see, it has become a what? Just normal true or false. True. How simple is that? How beautiful is that compared to this code? Compared to this code. So when does it happen? Well, it happens when there's no parameter and you're simply returning one thing. It can be string, it can be bool, it can be int, but there's no parameter that you need to work with. And if you're returning just one thing, yeah, you can simply pass one value. True, 139, Bob the developer, depending on what you need to return, but it makes your code so much readable. That's why when it comes to Swift APIs, you'll see a lot of auto closures like that. And then sometimes you might wonder, or you're returning true or false, but actually they are closure block, but they are auto closures, okay? Again, if you understand the why part, everything else becomes easier. If you want to learn more about auto closures, just search your API in the Swift document, and then you'll see a lot of auto closure and how it's being used, okay? So you'll learn how to use auto closures, when to use it, and the benefit of it, and also learn about escaping. And lastly, it's a bonus, which is lazy init with capture. So if you remember correctly from the last lesson, we talked about it. Lazy init, right? We talked about how to create a property using lazy closure. You might thinking there might be a retain cycle. For example, let's say we have I'm just gonna copy and paste. You have a code like this, Bob greet, okay, contains a name property, Bob the developer, and let's call this greeting string value, right? We are making an object using a lazy var, and then hello, and then this closure block has a reference to self. So right now, as you can tell, there might be a retain cycle, right? And then we have a D in it, I'm gone. So now let's take a look at this. So there might be a retain cycle you might thinking about, so you might have to use weak self, you know? We talked about it in the previous lesson, right? So let's create Bob greet, and then we created this object, and now let's do Bob greet. Let's try to initialize this property first. Initialize it. We've initialized this property, lazy greeting property, and then let's try to do Bob greet dot equals 0 or break the relationship equals nil. And let's take a look at it. I'm gone. Why is not being deallocated? Right there. I think I saw it. I'm gone right there. Yeah, let's try to remove this. Yeah, we don't need to call this. Yeah, I was like, why is it Swift or is Swift 4 different? Because right now on the left side is Swift. Yeah, I haven't updated Swift 3 to Swift 4, and I was like, why is it not working? Yeah, it was hiding in the middle of downloading. I was like, oh, but yeah, it certainly works. Yeah, I'm gone. Well, when it comes to lazy var, there's no reference cycle. Okay, what does that mean? When you're working with lazy var, it's non-escaping by default. Non-escaping by default. So when you're working lazy var, don't worry about retain cycle. Don't worry about putting like things like weak self. You don't need to do that when you're working with lazy var. So the lesson of this, the one thing to take away is, when you're working functions, if you're working functions and you have an escaping keyword, yes, watch out for memory management as well as retain cycle. But if there's nothing there, don't even worry about it. And also for lazy var, don't worry about retain cycle. It's non-escaping by default. Okay. Also, what I miss is autoclosure. Again, there's a lot of implication you can use autoclosures, so I'm not really going to talk about. You know exactly what to do with autoclosure anyway. So it was a great lesson. It took me a little while for me to get this thing done. If you have any questions, comment below. I'll be right there. I know this was a little difficult section. It took me a little effort to get this done. But hope you guys learned something new. If you have any questions, again, right there. I'm here for you guys. See you guys in the next lesson. In this lesson, you've learned 3 concepts. First, a function requires the escaping keyword if that closure parameter is executed or can be executed after the function returns and finishes. Second, autoclosure can be used to enter a closure block without any brackets. However, that closure block should have no parameter. And lastly, there's no retain cycle in lazy properties. They are non-escaping by default. By now, you've mastered closures in this chapter with me, so let me talk to you a little bit more in the next video.